Experiment-3. Aim of the experiment. The aim of this experiment is to identify the unknown salt by adding dilute sulfuric acid to it. The given salt can be one of the following: a sulfide, a carbonate, a metal substance, a sulfate. Theory. Sulfuric acid is a colorless, oily liquid that dissolves in water with the release of heat. It is important to handle sulfuric acid with extreme care, as long-term exposure to low concentrations or short-term exposure to high concentrations can cause severe injuries and adverse health effects. Concentrated sulfuric acid is particularly hazardous and can cause severe burns. It is widely used in industries and laboratories and is often referred to as the king of chemicals. The production and consumption of sulfuric acid serve as indicators of industrial advancement in a country. Apparatus and chemicals. The apparatus required for this experiment includes test tubes, a test tube holder, a Bunsen burner, dilute sulfuric acid, and the unknown salt, which can be a sulfide, carbonate, metal substance, or sulfate. Procedure. 1. Take a small amount of the unknown salt in a test tube. 2. Add a few drops of dilute sulfuric acid to the test tube containing the salt. 3. Shake the mixture well. 4. If necessary, gently warm the test tube using a Bunsen burner flame. 5. Observe and record the observations according to the provided observation table. Serial number. Experiment. Observations. Inference. 1. Place a small pinch of the unknown salt into a test tube and carefully add a few drops of dilute sulfuric acid to the salt in the test tube. A vigorous reaction takes place with the production of a colorless gas that has a characteristic smell resembling rotten eggs. This gas has the property of turning lead acetate paper black when it comes into contact with it. A rapid bubbling or effervescence is observed as a result of the release of a colorless and odorless gas. This gas has the ability to cause freshly prepared lime water to turn milky when it reacts with it. A vigorous bubbling or effervescence is observed, accompanied by the evolution of a gas that has a pungent and suffocating smell reminiscent of burning sulfur. The gas evolved during the experiment is hydrogen sulfide. This suggests that the unknown salt is likely a sulfide compound, such as sodium sulfide. The gas evolved during the experiment is carbon dioxide. This indicates that the unknown salt is likely a carbonate compound, such as calcium carbonate. The gas produced is sulfur dioxide, and the salt is a metal sulfate, such as sodium sulfate. 2. Place a metal strip of magnesium, zinc granules, or some iron pieces in a test tube. Add a few drops of dilute sulfuric acid to the metal in the test tube. A rapid release of bubbles or effervescence occurs, accompanied by the production of a colorless and odorless gas. When this gas is ignited, it burns with a popping sound. Furthermore, the gas does not exhibit any reaction or change when tested with litmus solution. Hydrogen is the gas. Precautions. Avoid direct inhalation of the liberated gases or fumes, as they can be harmful and potentially fatal. Take caution when handling glassware and promptly report any damages or accidents to the supervisor. When burning or heating a salt, always use a test tube holder to hold the test tube and maintain a safe distance from the burner. Exercise caution while applying heat to the test tube to avoid overheating and potential breakage. Be careful when exposing the gas to a burning wooden splinter, as it may result in an explosive reaction. Dilute concentrated sulfuric acid by adding it drop by drop into water. Adding water directly to concentrated sulfuric acid can generate excessive heat and cause the container to break due to the highly exothermic reaction.